Good evening, peoples. Return to my online class. You would have seen the video from yesterday and understood the concepts that were given there. Shall we move on to the session today? In this module, we will discuss the three different heat transfer modes one by one. There are three different heat transfer modes which are conduction, convection, and radiation. By conduction, what do you mean? Conduction is the process of transferring heat energy from molecules to molecules in solids by contacting them without their actual movement. Next, convection. Convection is the process of transfer of heat energy in fluids in which the heated molecules move away from the source of heat and cold molecules move towards the source of heat. This heat transfer method only occurs when particles are moving in liquids and gases. This does not occur in solids since the molecules are tightly packed in solids and there is no chance of molecules moving in solids. Third one is radiation. Radiation is the process of transfer of heat energy without heating the intervening material medium. The transfer of heat energy from a hot body to a cold body without needing any medium to travel and without being absorbed by the space between hot and cold bodies is called radiation. Radiation is the fastest mode of heat transfer. When radiation is absorbed by an object, its temperature rises. We receive the heat from sun through the radiation process. Next, I'll present a video to better understand the heat transfer process by conduction, convection, and radiation. Stay tuned.
When you hold one end of a metal spoon over a flame, why does the other end get hot? That's because the spoon conducts heat. Let's see an animation showing heat transfer through conduction. The particles of the metal spoon are tightly bound to each other at room temperature. Let's see what happens when we hold the spoon over a Bunsen burner flame such that only one end is in the fire. The particles of the spoon vibrate when heat is supplied and collide with each other, like the coins on a carom board, hitting each other when struck by the striker. Note how the heat energy gets transferred through particles. The transfer is always from the hotter end of the object to the colder end. Thus, heat gets transferred from one end of the spoon to the other through conduction. Conduction is the flow of heat energy through matter from particle to particle.
Heat transfer that occurs as a result of the actual movement of the molecules in a liquid or gas is known as convection. This type of heat transfer only occurs in liquids or gases because their particles are loosely bound. Let's see what happens when we heat water in a beaker. As the beaker becomes hot, it conducts heat to the water at the bottom. As the water at the bottom of the beaker heats up, the water molecules move faster and spread out. Because the water molecules are more spread, the hot water at the bottom of the beaker becomes less dense. The hotter, less dense water rises to the top, and the cooler water at the top moves to the bottom of the beaker. As the heated water molecules rise and reach the surface, they lose some heat to the air. The cooler water molecules move to the bottom, where they get heated up again and move back to the top. These circular movements or convection currents continue for as long as the water is being heated up.
Ever wondered how heat from the sun is transferred to our planet through space? It's through radiation. Radiation can occur in a vacuum, in the absence of matter, and without any contact between the heat source and the heated object. As the air particles close to the bulb get hotter, they vibrate faster. Heat from the bulb is transferred to the air around through the process of radiation. The transfer of heat energy by radiation does not require a medium. Let's see how heat is radiated from a light bulb. Initially, when the bulb is not lit, it does not radiate any heat. The air particles around the bulb are undisturbed. When the bulb is switched on, it glows and radiates heat. As the power supplied to the bulb increases, it radiates more heat.
One activity is given in your book. In that, we need to understand the transfer of heat into metals. To explain that, I'll be showing a short video. Watching it closely.
Conduction of heat through metals. One of metal's properties is that it is a good conductor of heat. By that we mean metal is a substance that heat can easily flow through. Let's try something that will help us better understand the conduction of heat by metals. For this experiment, we will need a Bunsen burner, melted wax, 5 or 6 1-inch nails with flat heads, and a thin iron rod. We will clamp the rod so that it extends horizontally from the stand. Using our lap tongs, we will grab the sharp point of a nail and dip the head into the melted wax. Attach the head of the nail to the iron rod. Do the same thing with the other nails, placing them at different points all over the rod. After the wax has fully cooled and the nails are attached to the rod, move the lit Bunsen burner under the extreme end of the rod. Very shortly, you should be able to see the nails falling off one by one, beginning at the end nearest the flame. This helps us to see that the iron rod is capable of conducting heat. As the heat generated by the flame is moving through the rod, it's causing the wax to soften again. Consequently, the nails will fall off. Different metals conduct heat at different speeds. If we were to repeat our experiment using an aluminium rod, you would see the nails fall much faster than they did from the iron. The conduction of heat involves the transfer of heat from one place to another. Inside the metal rod, the atoms are closely packed. When heated, the atoms will begin to vibrate. As the heat increases, the vibrations will also increase, causing atoms to collide with neighboring atoms. As a result, the vibration of atoms will move from the hotter end towards the cooler end, conducting heat through the rod. Summary: conduction of heat involves the transfer of heat from one place to another. Metals are good conductors of heat. All metals do not conduct heat with the same speed. Aluminium is a better conductor than iron. Heat is conducted through a metal due to the vibration of atoms.
Activity 4. In this activity, we are going to test the heat conducting property of different materials. For doing this activity, we need a heating pan, spoons made of plastic, steel, wood, copper and silver, heating arrangement and a block of wax. First we have to coat tip of handles of all the 5 spoons with wax. Take fresh cold water and put all the spoons into it and put the heater on. Now we have to watch this setup keenly. After a few minutes, wax on silver spoon melts first, wax on copper spoon melts second, wax on steel spoon melts third, wax on plastic and wooden spoons melt much later. From this we conclude that materials like silver, copper and steel which allow heat to pass through them are called good conductors of heat. Copper and silver are exceptionally good conductors of heat. Materials like wood and plastic that do not allow heat to pass through them are bad conductors of heat and are used as insulators of heat. Relative heat conducting capacity of metal can be graded as silver is the best conductor of heat than copper. Copper is better conductor than steel. Copy these 3 definitions neatly into your fair notebook while watching the beginning of the video. Learn and write the same definitions as homework 2. Thank you, children.